scientist of the season. And the partner I am with today is James from Flinn Scientific.
All right. Before we get to James, Simon, you have a couple of announcements here.
This is the last week of Simon the Scientist before summer break. We will have some unplanned, sporadic sessions during summer, so stay tuned. Last week's prizes are sponsored by Manitoba Possible. Winners are Lucy and Edward from Axdale and Bryson, Willow, and Capri from Churchill. Last week I was challenged to build a Thanos, a science vehicle, and an experiment machine.
That's right. So last week you had a Lego Science Day and you built an entire Lego Science Lab. And one of the challenges was a reverse challenge where they could challenge you to build something else. And you had 3 people challenge you to build something. So let's see what you got. You were challenged to build Thanos.
I got the big Thanos. Also, I added the little infinity gauntlet. I added Thanos and the little infinity gauntlet.
Very cool. Okay, what else did you get here? What else did you build?
The computer. A little futuristic computer.
Oh, can you tell about it?
Little computer thing. Little eye scanner thingy. Radio wave tower. Radio wave tower, the actual computer part, and an eye scanner thingy. So if anyone tries to find out my secret files, they won't find out because it has an eye scanner.
Cool. And then the last one you were challenged was a science vehicle.
So.
Whoop.
Maybe not by the helmet.
Maybe not by the helmet. Okay, go ahead.
So this is the driver, the steering wheel, the wheels, and it has 2 cool features. This is a solar panel for when it's out driving at day, but if I'm driving out at night, I use these 2 big battery thingies.
Very cool. All right. So Simon, you completed your challenges for last week. Let's talk about this week.
This week is a very special week. Prizes are sponsored by Flinn Scientific. Today our guest is scientist extraordinaire, James Palcik. Our challenge today is to stump James in any science topic you can think of. Our challenge today is to stump James in any science topic you can think of. Let's start asking James the tough questions right away.
All right. So let's start with introducing James here. Hello, James.
Hello, everybody.
And
pleasure to be here.
James, where are you coming to us from today?
Today I'm coming to you from my house in Hamilton, Ontario. I'm not down at the Flinn Labs because everyone's pretty much still at home, so we're going to do some science at home activities today.
That's
Great for the kitchen.
That's pretty cool because we're right here from home too, so everyone can participate in these at-home activities.
And we've also got a joke from Camille Wilson.
We do. We already have some hellos coming in, and we already have a joke. So, Simon, I'll ask you this joke, and then you can ask James the next joke.
Actually, I know what this joke is.
Okay, so let's ask James.
Why does the firefly get bad grades?
I don't know.
He wasn't very bright.
All right, now Simon's got one for you too.
I'm going to use that for the rest of the week, I promise you.
What were the chemist's famous last words?
I'm not sure. What were they?
And now for the taste test.
And now for the taste test. That's true. Never taste chemicals.
Yep. So James is big on safety, and that's one of the things that James noticed about Simon the Scientist too.
I sure did. And I noticed that Simon has his lab coat on, and when needed, he has his goggles on. And have goggles?
Well, mine are not clear. They're blue.
I know. I love them. But at a minimum, have some type of personal protective gear. And if you don't wear glasses like I do, you can even wear your sunglasses for some of these neat things that we're going to do that involve chemicals, salt water, detergents, just to be safe.
All right, so Simon, goggles on.
Glasses aren't that safe because chemicals can also come through the slits.
That is true. That is very, very true. So, does anybody have a stumper question for me yet?
Well, we don't have any yet from our audience, but we do have some from science, I was about to say, from Simon.
What happens when a black hole collides with another black hole?
Well,
There are two answers.
then don't ask me quantum physics questions and things of that nature.
Black holes are not super small. Quantum
No,
is
they're
small,
not.
cosmos is big.
They are enormous, you're right. And they're so powerful that not even light can escape from them. Did you know that, Simon?
Yeah.
Yeah, that's kind of an interesting fact, isn't it?
Yep.
But I have friends at the Perimeter Institute that would love to talk to you about those types of questions. I defer to those experts.
You know what that means, Simon?
I've stumped him
You've stumped him.
already.
So what's the answer? When two black holes collide, what happens?
There are two answers. Either it would create a supernova, like when a star explodes,
Clearly, yeah.
or it would just create a bigger black hole.
Clearly, yes.
There we go. Do you want to ask him one more stumper before we get started?
What is the biggest asteroid?
The biggest asteroid ever recorded? Like an asteroid?
Well,
that-
known to, well,
or
known
one
to,
that
well,
we've
known,
seen in modern-
well, known to mankind.
known to mankind? Well, I would say that would be the one that crashed into the ocean near Mexico and caused the extinction of the dinosaurs.
Wait, that was in the ocean? I thought it was on land.
It was the ocean in front of Mexico. Well, it's now an ocean today. It is underwater now.
Well, it is actually Ceres, which is 932 kilometers.
Ooh.
Pretty cool.
Lots of prizes from Flinn today. I can feel it.
Yes. So everyone get in your questions and you can ask James questions about any science topic you like and we're going to see if we can stump them. And just by asking a question, you are entered to win for this week's prizes. So James, I think Simon's ready to get started on any one of the activities you have for him.
Fantastic. Well, let's do a nice, simple conversation starter. Take a look at these three coins here.
Okay.
2 pennies and a quarter. You could use a nickel, dime, pennies if you still have them in a jar at home.
We have a penny.
Oh, that's great news. And I have pipettes at home. Sometimes people have pipettes. If you don't have a pipette, you could use a medicine dropper that you can get from the pharmacy or the grocery store, even the dollar store. If you don't have that, you can even use a nail or a little paintbrush. Now the question is, how many drops of water can we get to fit on the top of that penny right there? How many drops of water do you think will fit on there, Simon?
Oh, I don't know.
Well, take a guess, Simon.
Give me a number. Give me a number, my man.
2.
2 drops.
Pennies are quite small.
What do your followers say? Does anybody say more than 2?
All right, everyone, let's guess. How many drops of water can fit on a penny? Let's get in some responses.
Yep, and we'll put that penny right there, away from all the others.
Okay, and while we're waiting for some responses, Simon, you've got a penny here as well.
Penny.
And you've got some water.
Tomato.
And we even happen to have
A pipette. Also, you have a pipette, a straw, a tablespoon, and I forgot what it's called.
well,
Wait, a teaspoon.
and a teaspoon, yeah. So here's a pipette. So we have some estimates. We have Willow in Churchill says 1 drop.
I have a plastic nose.
Okay.
Bryson.
Willow, good guess.
Bryson says 3.
3 drops.
That-
Okay, Bryson.
Also from Churchill. We have 2 guesses coming in from Pianon Point. 26 from Morgan and 15 from Owen.
Those are high numbers, 15 and 26, okay.
Yeah, and I think Simon's sticking with his 2.
Simon's going to stick with 2.
I'm in the middle of Willow and Bryson.
Yeah. So we have some more guesses. CJ says 62.
And Isabel says 182. What?
And what does Oscar say?
6.
Oscar says 6.
So two Brysons equals Oscar.
Yeah. So we're going all the way from 1.
Down. Pretty much our lowest number is 1. And we go all the way up. What's the highest number?
182.
182. So that's quite a variance when you look at that.
I think
Number of pops that can fit on a penny.
I think you would have to take like a cup probably like around 1,000 centimeters each drop. 1,000 centimeters
Well,
each.
let's test that theory, Simon. Do you know how to use your pipette?
Yes, I do. You squeeze the top part, then it will suck up the water.
And then you put it inside the liquid and carefully open it up, and you'll see. Can you see that it filled up inside the bulb with all that liquid?
Yeah, mine's just sticking at the end for some reason.
All right. So you want to count together?
Yeah, sure.
Okay, so we have James doing his, and we have Simon's doing his, and I can kind of see both at the same time. So Simon, you just have to make sure that it's 1 drop at a time, not a whole bunch at a time. Okay, so don't touch the penny. Okay, Simon's got 1.
Okay, we'll let Simon
2,
do his, and then I'll do
3,
mine.
4, 5, 6, 7, not too fast, 8, 9, 10, 11, don't touch it, 12, 13, 14, 15, oh, don't wiggle the table, 16, 17, 18, 19, 20, oh, careful, 21, 22, 23, 24, 25,
26,
don't touch it,
27, 28, 29, 30,
30,
31, 32.
oh, there, then it spilled
It was
over.
32.
32, I bet you, Simon, I can get more than 32 drops on my penny.
Contest accepted.
Drops for me.
Okay, let's count with James.
Contest accepted.
Ready? Can you see it's almost about to come out? You see that?
Yeah.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44,
I want to see
45.
what it looks like like in 3D.
47.
That's by 17 drops farther than mine.
Now, what are some variables involved with just that simple experiment right there?
Physics?
Okay, physics, chemistry, all kinds of things. But what are the specific variables? So let's look at that.
So Simon, or let's tell everyone.
Wait. Surface
larger than mine.
So let's talk about the variables first. So what are the things that could have changed in your trial and James's trial?
Well, James was doing it like small drops, like not too far away from each other drop.
Yeah. So your technique is a variable. What else is a variable?
Size of the drop.
Oh yeah, you're doing very small drops.
Yes, indeed.
I wouldn't just do one big blob.
Now, what's that?
Dawn dish soap.
Dish soap. Okay. So I'm going to move that same penny. I dried it off. I'm going to put it right over here, okay?
Okay, so we have to dry off our penny, and we're going to move our penny over too.
And did you see what I did? I put a tiny little drop, just a tiny little drop of detergent on my finger. Do you see that?
Yep.
Blue?
Yeah.
If I just put it on the top of the penny, what do you think will happen with the drops? Do you think it will form a nice big soap bubble and I'll get 100 drops on there? What do you
Well,
think?
actually, it will just fall off because the dish soap would break the tension of the water.
Ooh, very good. So you're talking about surface tension, cohesion, micelles, things like that. So let's test your theory, shall we?
Stump.
Oh, just wait. We'll do this one first, then we'll get to the questions.
Big bubbles. Bubbles. Mini ants.
I only got 12 drops on there. And then you're right. It won't stick on there now.
Okay, now we'll try.
Okay, well, let's think about why. Okay, you want to try yours with some dish soap? So put a little drop on your finger. Where's your finger here? There we go. Oh, we put a little bit more on. That's okay. Put it on your penny.
Sticky.
Yeah, it's a little bit sticky. Okay, and now you're going to try again.
Just more than 12.
So do the same that you did before. Now we're not, are you going to try to beat James
Yeah.
this time? See if you can get more than 12. Okay, right on the penny, not on the side. 1, 2, don't touch it though. Let it fall off. 3,
4, 5, 6, 7, 8, 9, 10,
go slow.
11, 12, 13, 14, 15, 16.
Look at what's happening. There it is. Yeah.
16.
Sounds like you beat me.
16. I beat you by 4.
Good for you, Simon. Good for you.
But guess what? The trial that you did without the dish soap, you had many, many more. And the same thing happened for James.
Yeah.
All right, James,
This is all very...
do you have any questions?
I have a question.
I like questions.
After we're done with the drink part, is anyone going to drink those?
Oh, we're not even there yet.
We'll get to that part soon, I promise.
Okay.
Okay. So we have a couple people chiming in from our audience.
Give me the feedback.
Yeah, Morgan says it's all about surface tension. Our friends up in Churchill also identified a variable as the size of the drops as well. And Willow thought that it would create one big bubble.
Well, in a way, it did create one big bubble,
Oh, here.
but
Oh,
it wasn't able to stick to adhere to the surface of the coin, so it just washed away. Whereas when it's just regular, dirty coin, it was able to stick on there, and it was a big water droplet, a big half dome was created on there.
That's pretty
So
cool.
when you're in school or you're in a lab and you're working with a graduated cylinder and it's filled with a liquid, it always curls up at the top. And that's called the meniscus. And that meniscus is formed because of surface tension and cohesion.
okay.
The same thing happens in a water glass. It's just a lot more difficult to see.
So what exactly happened here? And what does this have to do with, even more so, with chemistry?
Well, there's a lot of chemistry going on there. You can add a catalyst, which is something that will change the behavior or change or stimulate a reaction in your experiment or your activity. So we added dish soap. And the chemical inside of dish soap, the detergent part of it, is called SDS, or sodium dodecyl sulfate. But you already knew that, right, Simon?
Yeah.
Good. I thought so. And the chemical that we used as a liquid, you guys call that water. Is that right?
Yeah.
You want a much cooler, like a scientific name for water?
H2O.
H2O, and if you say that as if it's a chemical, it is dihydrogen monoxide. 2 hydrogen, 1 oxygen. Dihydrogen monoxide, singular. H2O.
Give that a try, Simon. Dihydrogen.
Yeah, dihydrogen monoxide.
Your turn.
Dihydrogen monoxide.
Very good. Very good.
Amazing.
Now, oh, go ahead.
Once we're done, we do have a couple stumpers for you, but we'll wait until we're all finished with this activity first.
Well, I'll take the stumper now.
All right.
I'm feeling like I can't lose this one.
Okay. So we've got 2 stumpers. The first one's coming from Morgan in Peanon Point. If the fire in a blacksmith forge is hot enough to melt metal, why doesn't the forge itself melt?
Well, maybe
Great question.
I have an idea.
Sure, what's your idea, Simon?
Maybe the metal surrounding the fire is like an alloy to make a stronger metal compound, and the metal that the blacksmith is using is just like a normal metal itself.
Oh, Simon, how do you even know these words? That's pretty awesome.
Because I'm a nerd.
Yeah. James, what's your response?
Well, it depends on the type of forge. I'm going to go use the term blacksmith and frame it in that era. Simon is correct in that the forge itself was created with 2 different materials. It also had clay bricks inside it that would insulate, keep the heat inside without letting it go out into the metal and totally cut apart, but keep all the heat inside where they could keep putting in that sword or that shovel or the axe and just pull it out, keep working on it, then they would do a whole bunch of other things afterwards. But it's the law of thermodynamics that played there.
Amazing.
I thought you were going to ask me, why doesn't crazy glue stick to the inside of the bottle and then you have no crazy glue because it sticks to everything?
Well, that's a whole nother question. Now Simon's looking a little perplexed.
That's my Simon stumper for you. There you go.
Yeah, that's a Simon stumper.
Okay.
I have another stumper coming in from our audience here. Isabel has a space question. What is the temperature at the moon and outside of our galaxy?
I
That
think
is
I
right,
think
and it depends if it is in the sunlight or if it is in the shadow. Because just like on a sunny day, it's warmer in the sun than it is when you're in the shade with the same sun. Would you agree to that?
Yeah.
Okay, well that's good, because that's true. It is very, very cold on the surface of the moon. Like negative 200. I don't know the exact numbers because it's been a long time since I was in astronomy. But it's very cold. But it also can get quite warm directly in the sun. Why is that?
It can also get warm if it's a solar eclipse happening.
Yeah.
That's true, but also the moon is in space, so there's it's almost like a vacuum that's there, but there's still heat that moves and particles still move. Great question.
I have an answer for that question as well.
I figured you had an answer, Jack.
So, in our planetarium that we take around, Iggy, we have one of our science shows in Iggy talks about the temperature, that it goes from plus about 150 to 200 down to minus 150 depending on the sun or shade at that moment. And that the temperature difference is so extreme because the lack of atmosphere.
Yes.
So we don't have clouds or anything else like that to retain any heat or to buffer out any heat as well.
Sunsets on Mars are blue.
Sunsets on Mars are blue?
Yeah.
Interesting.
I did not know that.
Who knew iron gas was blue?
Yeah.
That I did know.
Okay. So, I think we can keep taking in these stumpers, but it's time to get to our second activity here.
Absolutely.
Bang,
Did you
bang.
see my fancy custom fabricated signage I did today? Number 1, number 2, number 3. Would you agree? See that? 1, 2, and 3?
Yeah.
I have 3 glasses of water. I have 3 eggs.
Oh, and here we have 2 glasses of water. Hang on, we'll just get rid of our penny stuff here. We have,
I'm special, so
Yeah.
you should only have 2. I'm going to do some magic for you guys today.
we have 2 glasses of water and we have 2 eggs as well.
Okay.
So hang on, Simon. Just leave them in the dish. We don't want them accidentally breaking.
Can we make icing out of
Safety first,
these?
everyone. Safety first.
Yeah, into the dish, please, Simon.
Why can't we make cake out of the eggs?
Well, we can afterwards. We can reuse them.
Yay.
So, Simon, goggles on, though.
Yes, please.
All right, so James, you can walk us through this.
Blue goggles.
What we have here are 3 regular eggs that you would get at the grocery store or from your farm. I have 3 identical glasses filled with a clear liquid, dihydrogen monoxide, which is what, Simon?
H2O or water.
Excellent. Now, over here, if I was to drop this egg, okay, so let's just look at this this is my pretend aquarium here. If I take this egg and I drop it in the aquarium full of water, what's going to happen?
The egg will.
Or is it going to float?
I think it is going to float because the liquid in the yolk in the egg is like inside of the egg isn't just all yellowy stuff.
Okay.
So
What does the audience say? Do they agree with you?
Yeah, let's get in some responses. Will the egg sink or float?
if it has air inside the egg, it would most likely float. If it's just the yolk inside the egg, then it would sink.
All right. So what do you think, Simon? Sink or float? Only one.
Float.
Float? Okay. What does the rest of the audience say? Sink or float?
Bryson and Willow say sink. Morgan and Owen say sink.
Oh dear, okay.
I'm getting outnumbered already.
Yeah, you're outnumbered already. All right, let's see do you want Simon to do his first or you do yours first?
Just
Well,
remind me
I'll tell you
before
what.
everybody said sink and it floated.
Let me do this one first, then we'll do some fun. We'll have some...
Oh, guess what, Simon? Isabel agrees with you that it'll float.
Okay, well,
Yay.
let's see if Isabel and Simon are correct.
I'm rising.
Okay, let's check it out.
Oh my goodness! It's down there in the bottom. Can you see that?
Simon?
Okay.
Right to the bottom like a stone.
Well, maybe it's because the egg doesn't have any air inside.
Oh well. So what do you think will happen in this class, Simon? Sink or float?
Maybe sink?
Or maybe float? So which one would that be?
Float.
Just commit to one. Sink or float?
Float.
Float?
Nope.
Right to the bottom. How about this one, number 1? Sink or float?
Song.
Oh,
And how about this one?
That one took, float. Yay.
Ho, 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 ho. Now, what is happening here, Simon? I want you to use your scientific genius nerddom knowledge and explain to me why I have 3 totally separate results. What has happened?
Physics has happened.
can you explain it?
Because
Well, the surface tension, might have, water kind of defies gravity. There.
If you're unsure, it's okay to say you're unsure.
Water defies gravity. Water is the only natural thing that defies gravity.
Yeah, so it could have to do with gravity.
Because instead of going down in water, you go up.
Okay.
so how do I give a little hint?
Or maybe
Oh, look, he's going to give you a hint.
Or maybe each. Oh wait. Maybe. I was going to say maybe each glass is a little bit more dense.
Oh, yeah. And we have another guess too, or another prediction that it's because of the age of the egg.
Oh, that's a great thing. Now, okay, so let's do this. Let's do this. I want you guys to watch, okay? I will take egg number 3. And I will change it with egg number 2. What do you think will happen with egg number 2? Is it a magic egg? Is number 2 going to float or sink in here?
I don't know. I'm gonna maybe
It was just floating right here. What's going to happen
I
now?
think it might sink.
I agree. And this one
Will probably float.
will probably float.
So it's the water difference.
What does that tell you? If it's not the egg, it's got to be the...
Density of the water?
Yes, it does have to do with density of the water. But why is this one at the halfway point? It's kind of neutrally buoyant. You see that? It's halfway down, halfway up. Can you explain that one to me, Simon?
Is it because the egg is the Titanic that fell on the cliff of the ocean?
Sadly, no, it is not.
Okay.
And it is a magic one either, because if I put it in there, that will... Oh, look, it's at the same height there that it was over here.
Well, maybe it's because that egg is balancing on the other egg.
That was exactly right. Great. So there you go. That one will now sink to the bottom, and if I put that in here, it should... Oh, look at that. Simon, explain this to me, because I don't understand.
It's
What?
called magic.
Okay, listen.
It's called magic. It's science we don't understand yet.
It's kind of magic. Well, it is kind of magic.
Magic
So
is
what
science we
told
don't
you
understand
that-
yet.
These were all regular warm water. Okay. But this one, I put a lot of salt in there and kept stirring it down until I had a very saturated saltwater solution.
I don't,
I kept testing it to make sure that I would get the egg to float all the way to the top.
well, maybe it's because, the salt is floating, which is forcing the egg to float too.
Partially, yes. So I've changed the density of this water by adding salt or sodium chloride to this water. This one is just regular H2O. This one is H2O plus NaCl, which is sodium chloride or salt. But how do you explain this one?
My
Number
brain
one.
is so messed up right now.
Good. I stumped you.
Again, yes.
So, you
I'm just a kid in second grade.
That's my stumper. If anybody can tell me how that happens, you get a prize from me.
All right, so we do have some thoughts that came in earlier. So one was that items can float in salt water. Another one was about water temperature. We had another one about salt water as well. So now we know, because you've said that all glasses have the same temperature of water, a warm water. And we also know that you have salt added to make the egg float.
It was added to number 2.
Yeah.
Yes.
And now we've got the suspending egg, and if anyone can tell why.
Well, here's maybe one.
Sure, what's your idea, Simon?
Maybe because, well, this is probably not true, but, eggs are usually, like, sort of oval shape, and that one is kind of circle shape, so that
All
egg.
the identical.
So the first one might not be an egg, and you're trying to trick me.
They
But-
all look exactly the same. They're all identical, Simon.
But Simon, do you remember he even changed the eggs from the different glasses around, and they still did the same thing? Right?
So what does that tell you? We were talking about some variables earlier on.
Well, maybe.
Okay, so we have one guess that it's only a little bit of salt.
Well, I was going to say that, so congratulations.
Oh, you both have the same answer. Only a little bit of salt.
Well, there is a secret to this. And the secret, there's 2 ways of doing it. If you have a funnel, a long funnel, and you take some of the salt water from this solution, or this glass, and you pour it into the bottom, and bring it up to about this mark, right where the egg is balancing, you then very slowly add water on top as a distinct layer, because fresh water will sit on top of the salt water. So I'm giving you a hint as to what's happening over here with number 2.
Oh.
What kind of water is more dense? Regular fresh water or salt water? Which one's more dense?
Salt water because it has an extra thing added.
Very good.
I am just so confused
What do
right
you think
now.
happened here?
Adding salt water on the bottom and water on the top, and then putting the egg there, because that's what you said how to do it.
Okay, now watch what happens if I take this and I pour it in here.
Huh? maybe it's because the water switched sides, because like salt water and just normal water, then salt water and then water and salt water.
Did I stump you again?
No, not really. I think that
James, we've got a lot of good thoughts coming in here.
What has happened, there's lots going on, is that on the bottom initially was very dense salt water, and I carefully layered fresh water on top of it, and I didn't let them mix. When I agitated that mixture by pouring it into the second glass, this one, all that water mixed together, and there was not enough salt in the solution to make it buoyant like it is here. So it went down to the bottom. Okay? See all this fun stuff you can do in your backyard at home?
Well, James, I think you're going to be giving away a lot of prizes. Morgan and Owen had guessed that it's half pure water and half salt solution in glass 1. We also had another comment that the eggs float because there's more salt in the water, just like the Dead Sea, where you can only float. We had another comment that fresh water is on top and salt water is on the bottom.
Excellent.
Very good. So, Simon, you have 2 glasses here. Now I want you to tell me with your eggs which glass has salt water in it and which glass has fresh water in it.
This one looks clear.
Nice and loud.
And this one has more white thingies, and this one is like just clear.
Okay.
So let me guess, this is the one with salt water or a mixture of that, and this is just regular water.
Okay, so you take 1 egg and let's see what happens. Oh, all the way to the bottom, which tells
so
us.
That's regular water.
Okay, now let's test this glass.
This might be the middle one. Nope. Well, it's like a little white island.
Yep, it floated. So what's your guess? Sink and float?
Salt water, regular water.
Very good. And that brings us to our 3rd activity here. Our last activity of the day. So we need you guys to bring in some more stumpers for James.
Salt, normal.
All right.
That's...
We've been talking about chemistry of different things. We've been talking about density of different things. How many of you guys drink pop? Probably everybody.
No, not me.
But that's a great answer, Simon. So, Simon, can you see what that is?
That's 7-Up.
Do you think that this can of 7-Up will float, or do you think it will sink?
Probably float, because, if you open it, it would not just be like, hey, let me out, I'm at the surface.
That's true, but I'm not going to open them. So let's see what happens with your 7-Up.
They don't want to go. Nope. It kind of floats, kind of not.
It does. What do you think will happen with a Pepsi?
AKA my mom's favorite drink.
Okay, what do you think will happen with your mom's favorite drink?
Float. I'm smart.
Oh, what about orange Fanta?
Float.
What about that one?
Float. Float.
See? Oh my goodness. Do you see that? Went right to the bottom.
Also, you landed it. You also landed it.
Hi. Here's a Pepsi Zero.
Wait, is that the kind with no sugar?
Pepsi Max Zero Sugar.
Okay. Float again.
Comes right.
Float army is beating the sink army. Float. Ah, yay.
A Pepsi Vanilla.
Float. I'm winning. Oh wait.
Oh, look
No,
it, look
no.
it.
beer right to the bottom.
So, sorry? So,
A Red Bull edition. What about that one?
I don't know. Red Bull, please float, please float.
Oh, look, it's suspended for a moment.
Yes, float, float.
Zero sugar, Coke, orange, vanilla.
Okay, please float, yay.
Now, Simon,
What?
I want you to figure out why some of these have gone right to the bottom and why other ones are floating.
Maybe it's because the ones that are floating have small air sockets and the other ones don't.
So there, take a good look at this. You see that?
Oh wait, some of them are flipped upside down.
Well, yes, they flipped upside down, but do you see that they're floating in there?
Yeah.
James, we have a comment here.
Okay.
Red Bull doesn't give you wings because it's sunk.
That's worth a prize right there alone.
All right, so Simon, I want you to try your cans too and think about why this is happening. So we have some here as well. We have Sprite to start with.
Right.
Okay, go ahead, Simon.
This is not the one in the big green bottle. Oh.
Okay, let's see.
Oh. It
Go
looks
ahead,
like it has
drop
a big
it.
booty.
Drop it.
Yeah. It looks very, very big.
So the Sprite sunk right to the bottom.
Your hand looks
Whoop,
very big.
I
now.
overflowed. I overflowed us here and I got Simon wet too. You
Don't
okay there,
get
bud?
me Don't get my beautiful coat wet.
Okay, we have grape soda. Go ahead, Simon. What did the grape soda do? We have to tell James because he can't see us right now.
It sunk kind of. I'm getting away from here.
Well, why don't you reach in so that your hand is smaller than mine? It won't displace the water as much. Okay, grab the grape soda sunk right to the bottom for us.
Grape. We got some sour grapes.
Okay, we have ginger ale. Go ahead, Simon.
Ginger ale. Ginger ale. Ginger ale. Ginger ale.
Oh, what did that one do?
Sauce spoon.
It's suspended.
It's sauce spoon.
It's starting to go towards the bottom, but it's mostly suspended. Okay, take that one out. We have 3 more here to test. So far we've got 3 for 3 have sunk. And we've got a big mess too, which is always fun.
No.
Okay, we have Orange Crush.
I'm just gonna drop it. Why is everything sinking?
It's sunk as well.
The
We have
sink-
2 left.
The sink army is beating the float army.
We have root beer.
Please float.
Oh, look at the root beer. It kind of suspended, but then
Float.
it's kind of floating, but I think it's slowly sinking back down too.
Come on, come to Papa.
And our last one,
It's floating. It's floating.
our
Mom's
our last one is Diet Pepsi that we're gonna try.
What do you think will happen? Do you think we'll sink or float, Simon?
float. It's floating. Yeah.
So really, out of all of ours, the only one that floated was the Diet Pepsi.
And why is that, Simon?
Maybe it's because there's an air socket on the Diet Pepsi and none in the other ones.
Not air, it's
Density?
sugar.
Sugar. Okay.
The sugar content inside those different products. So when I dropped the Fanta in, it went straight to the bottom. But if you use something with no sugar, 0 sugar, a diet version of something, it tends to float. Okay? And it's floating because it is more dense or less dense than the water.
Less dense?
Very good. And why orange Fanta down on the bottom?
Because it's more dense.
It is more dense
I
because it has all that sugar inside it.
I always thought middle.
Sugar inside makes that dense. So density is the measure of mass over volume. And these are the same size, have the same volume. So density is which one weighs more.
Well,
So we could put these on balance.
I think we can know how. I think we don't even need a scale for that. We could just go close up on the bottle and see how much it weighs.
Well, it'll tell you what the volume is on the side of the can, but what it won't tell you is how much mass is, because they don't want to tell you how much sugar is in there. Okay? But one of our next activities, we can actually figure out how much sugar is in these. Okay? All right, Simon, do you have any more stumpers for me?
Yeah. I don't think these will stump you.
Okay, let's give it a try.
Okay. What's the most dangerous acid?
Well, that's a great question. I'm going to answer that question from my experience. All acids are dangerous if used improperly. Acids need to be stored properly and safely. Nitric acid in proximity, so just close to acetic acid, can actually explode. All right? But I'm guessing you wanted me to say something like sulfuric acid. Is that the one you were thinking about?
No, it's actually a super acid named fluorosulfuric acid. It's 1,000,000 times stronger than sulfuric acid.
That is true, but you can't find that easily. You need to have special licenses for that product, okay? So follow your teacher's instructions, wear your goggles, wear your lab coats, wear your aprons, all that stuff. Follow those instructions to the letter, okay?
Are lab coats just to look cool, or is it for safety?
It is for safety. If you think that wearing goggles makes you look cool, that's great. But it is for safety to protect your eyes.
Lab coat also makes you look cool, and that's also for safety.
It's both?
Yeah.
Lab coats do make you look very cool.
Very cool.
All right, James, we have a couple more jokes here from Simon. And while he tells those jokes, we'll let our audience know it's your last chance to stump James. However, if you come up with questions later or you're not watching this live, you have until Friday to ask James a stumper. You can just put it in the comment section at any time. So Simon, a couple more jokes.
A dung beetle walks in the restaurant and says, "Excuse me, is the stool taken?" Stool is another word for poop.
I got it, don't worry. That's it. Simon.
Now, Simon, I would like you to tell the last one on the page nice and loud so James can hear it.
Okay. Why did the physics teacher break up with the biology teacher?
Why did the physics teacher break up with the biology teacher? I don't know. Oh, I know. Because there was no chemistry.
How do you know?
He got it.
I got it.
All right. Do you want to say one last one then? How about number 4 there?
I know another science joke. It's on the tip of my tungsten. Tungsten as in the element, and if it's on the tip of your tongue, that means you can't really say it.
Gotcha.
Good one.
Very good.
All right.
All right,
So
I have to go back to the actual Flinn lab now.
Can we see it?
Can you see it? Sure. The next time we'll do one from down at my lab, okay?
Yay!
All right.
okay. So what do you have to say to James?
Bye.
And
Thank you.
You're very welcome. Thanks for spending time with me today.
Bye.